Okay, so now I'm going to look at a redox reaction. So there's two types of redox reactions. One is in an acidic solution, and one is in a basic solution. And they're both balanced in similar ways, with just one difference. In the case of an acidic, the way to balance your charges in a redox reaction is by adding protons, or H plus atoms. The way that you do a basic one is you add OH negative to balance your charges. In either solution, you have to add water because all of this happens in an aqueous solution. So first I'm going to do an example of an acidic. So the first thing that you do is you write something known as half reactions. So basically the way that it works is I look at my irons alone, okay, and I'll have Fe2 plus goes to Fe3 plus, and if I go from 2 plus to 3 plus, that means I've lost an electron, which means that in my product side I'll have to show one electron that's lost. Okay? Then I look at my manganese, which is the MnO4 negative goes to Mn2 plus, and basically what you have to do is you have to add oxidation numbers, and that'll tell you if you're going to be gaining or losing electrons. This first one was easy because the oxidation numbers were actually given. The oxidation number is a charge on the individual atom. So I'm going to do this in a different color. Let's choose red. So since my first iron already has a 2 plus charge, my oxidation number will be plus 2. Manganese is kind of hard. Manganese has more than one oxidation number, so I'm going to look at the oxygen first. So the oxygen always has a -2 charge, unless in certain situations when it's in a peroxide or in a solution with chlorine. So since that's the case, this is -2, and since I have 4 oxygens, that means my total oxidation for oxygen is -2 times 4, which is -8. Okay? Now, the way that you find out what it is for the manganese, which you clearly know that it will be positive because positive attracts with negative, what you have to do is make like a mini equation. So, you know that -8 plus x will give you a -1 charge. Because if you look at this molecule as a whole, it has a -1 charge as a whole. So my overall charge has to be -1. So when I solve for x comes out to be +7, which becomes my oxidation number for my manganese on this side. Now, this one is also in its molecular state, or its atomic state, which means that it'll be +2 since the charge on it is +2. And the iron is also in its ionic state, so it'll be +3. So now you see that it's going from +7 oxidation to +2 oxidation, which means that I've gained 5 electrons. So now on my reactant side, I have to add 5 electrons. And this will tell you if it's a reduction equation or an oxidation. So the way that I usually remember this is a saying called oil rig, which means that oxidation, the oil part, means oxidation is loss of electrons. Okay? Redox, therefore, is the gain of electrons, which is the rig part. So, we can see then that my iron, since it's losing an electron, it's the oxidation, which I'm just going to abbreviate as ox. And since I'm gaining electrons to change my manganese permanganate into manganese 2 plus, that will be redox. Sorry, my reduction. Okay, so now that we've determined which ones are oxidating and are reducing, it'll make things a bit easier. So the first thing that you have to do is you have to balance your electrons. So in my first equation, I have 1 electron. In my second one, I have 5. So I have to multiply this first equation by 5 so I can cancel out my electrons. So I'll have 5 irons on either side, 5 electrons, which they'll cancel out with these 5 electrons. And I don't touch my manganese because that's fine as it is right now. So next thing you can also do, writing these half equations, is balance your charge. So you have a -1 here and a +2 here. And since this is acidic solution, you only have positive charges that you can add. So you have to add 3 H pluses to my manganese. For this, I have to add, let's see, it goes from being +2 to +3, which means that I've lost an electron, which means that I have to add 1 H plus on this side. But since there's 5 on either side, I forgot to do this part. I also have to multiply this by 5 to balance everything out. Then you just add these equations and you find that on this side, you have to add 8 H pluses. So once you get this balanced, now you have to balance your hydrogens. And the way that you do that is you just add water to the opposite side. So since I have 8 hydrogens here, I just have to add 4 waters, and that should allow everything to balance. And that's in an acidic solution. And that, my friends, is your balance equation in an acidic solution. So now the basic solution, which is just the opposite. So instead of, I'm just going to wrap this up really quickly, but you have the same steps, but instead of using H pluses, it usually gets flipped, so you end up putting water on the one side, and you have 8 OH minuses. And this should be an 8 if I want to, sorry, this should be, yeah, it should be a 4. And that's what a basic solution would have. So I just want to let you guys know that if you can get how to do an acidic solution, doing a basic one is really simple. Thanks, guys. Subscribe to me so you guys can see some cool videos doing science and experiments and maybe learning something new. Thanks.